Welcome to CEC lectures. Myself, Dr. Preeti Chagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So, in the series of operating system concepts, you must be aware that presently we are going through the topic of memory management, and in our previous lecture we have seen about we can say very basics of memory management. For example, what is memory management and what is its needs, and some other concepts about it. So today I'll just take a very quick recap or very brief recap of what we have learned about memory management, and then I'll proceed with this particular lecture whose agenda is address binding. So memory management, as we know that we need this memory management as an exercise to be done by operating system mainly, because we need to increase the CPU utilization and we need to increase the degree of multi-programming also, because then only you will be able to utilize your system resources up to its optimum. So basically what is happening, let's take an example of the one program which is to be executed on the system, and that program is residing on the particular disk or on a disk, we can say, which is our hard disk, and this program is residing there as a binary executable file. Now how this program is to be executed, and what is the scenario of memory management, or where all this memory management is required during the course of execution, that we are going to see in this lecture. So this program must be brought into the memory and placed within the process for execution, because we have seen in the earlier lecture that whatever is inside the main memory or whatever is inside the registers, that can be accessed directly by the CPU. This disk storage is not accessed directly by the CPU. So disk storage, whatever we need to execute, has to be brought into the memory. So that means there is a kind of, we can say, a movement from disk to memory, and it could be vice versa, and this all thing is required for execution. And this movement of the processes between disk and memory is going to we can say generate the formation or generate the input queue, because input queue is something which is going to contain all these processes. Now when the process, for example, when we are that program or process is brought into the memory, then also that process goes through several steps, that program, that algorithm goes through several steps before being executed. Now what steps I am talking about is about the generation of addresses, we can say. So addresses are required to be represented in different ways during all the steps, during various steps of programming execution. And what various steps of programming execution I am talking about are, these steps are the compilation thing, then we have the process which is done by linkers and loaders. So basically linking, loading, compilation, and then finally running of the program, or which is the main we can say execution by the processor. So addresses are to be represented during all these steps which we have just talked about, and addresses in the source program are generally symbolic. Now what is a symbolic address? So symbolic address is, for example, let's say a variable ABC. So for a particular program, that ABC could be one of the addresses or one of the locations where that particular variable is being stored. So this is what we call the addresses in the source programs are generally symbolic. Now what a compiler is going to do with these symbolic addresses is the conversion of these symbolic addresses into relocatable addresses. So for example, we have a variable ABC, and then the compiler during the execution of the complete process of execution of the program, the compiler is going to bind this symbolic address ABC to a particular relocatable address, for example 28 bytes from the beginning of this module. That's kind of a relocatable address. So now onwards, that is not taken as the variable ABC, but that will be taken by the number, or kind of by the address saying that 28 bytes from the beginning of that particular module. Now, for example, the next step comes as in, we talk about the linking and loading. So, here are the modules which are linkage editor or loader, and these linkage editor or loaders are going to take these relocatable addresses to the absolute addresses. So, relocatable addresses, as I told you, 28 byte from the beginning of this module, and then these will be converted into the absolute addresses. For example, any memory number, for example 2046 is the memory number which is given to a particular relocatable address. So, that is going to be an absolute address. And after conversion of relocatable addresses into the absolute addresses, we are the next step comes up is about the binding, which is the assigning a physical memory region to a logical pointer by mapping a physical address to a logical address. So, basically binding is all about mapping a physical address to a logical address. This logical address is also known as virtual address, and this is actually we can say assigning a physical memory region to a logical pointer, and this will be done by this mapping of physical addresses into the virtual addresses. Now, basically who is going to do this binding thing? So, if we see this binding process on its core, this is we can say a component of computer memory management that operating system is going to perform on behalf of applications, all those applications who require memory access. So, operating system, or we can say component of memory management of operating system is going to do this particular task. So, that means some addresses are to be we can say bind. So, for example, the compiler is going to take the the addresses as in symbolic addresses. For example, variable ABC, that's also an address for compiler. Then at the step of linking and loading, these addresses are converted. Before that, these addresses are converted into the relocatable addresses. Then at the step of linking and loading, this relocatable address is taken and then converted into we can say absolute addresses. But these absolute addresses are actually the addresses of we can say physical memory or physical addresses, and these physical addresses are again in the next step are going to be assigned to a logical address, and this step is known as address binding, which refers to mapping of computer instructions and data to physical memory locations. So, both logical and physical addresses are used inside the computer memory, and here now onwards we will learn about this logical versus physical address space into detail. So, basically we are going to learn the we can say process of binding, which refers to mapping of computer instructions and data to physical memory locations. And when we talk about these address binding, we have two concepts here. One is logical address space, another one is physical address space. So, we can say an address which is generated by CPU is kind of a logical address, and that address can be seen by the memory unit, that is which is one loaded into the memory address register of the memory, and is commonly referred to a physical address. So, basically we have the logical address which is generated by the CPU, and this logical address has to be converted, because my user program never sees the real physical addresses. User program always always works with the logical addresses, and there is a memory mapping between logical addresses into physical addresses. And who is going to do this memory mapping? This memory mapping is done by a memory mapping hardware, and the hardware basically, you know, we say the core unit is memory management unit and memory mapping unit, and that memory mapping unit is going to convert this logical addresses into physical address. Now obviously this address is going to be changed because earlier the mode was different and now we are changing into a different mode. So the final location of a referenced memory address is not determined until a reference is actually made. So basically two types of logical addresses, one is two types of addresses, one is logical address, another one is physical address. So logical address we can say are in the range from 0 to max, and when these logical addresses are converted into physical address, there is involved one, you know, value which is known as base value, and this is related to a register. I will be shortly covering that. So logical address is basically in the range 0 to max, and then we have a physical address which is in the range of r plus 0 to r plus max, where what is this r? This r is a base value which is stored inside that register. So for example, if I am having a value from logical address from 0 to 150 and I am having the value of base registers as 200, so whatever my physical address will be, that is 200 plus 150, which is the maximum range of the logical address. So physical address will be from 200 to 350. So basically in the range r plus 0, from starting from r plus 0 to r plus max, where r is the base value. And user program, as I told you, generates only logical addresses, and user program is under the impression that the process is running in the location 0 to max, because the user program is not having any idea about the physical addresses, which involves the interference of a value which is being added here, and that is the base value r. Now these logical addresses must be mapped into physical addresses before these are to be used. And this concept is, you know, kind of we can say is core concept of the memory management thing. So now till this point we have, you know, we are very sure that there is, you know, the step of while executing a program, there is, you know, compiler which is going to deal with addresses, then we have a linker, then we have a loader program, and all these are going to, you know, kind of we can say translate the addresses from one form to another. And whenever we talk about translation or binding of addresses from one type to another, so that is a binding is basically a mapping from one address space to another. That could be from logical address space to physical address space and so on and so forth. So now when we talk about, you know, how many types of binding, this address binding is to be done, so we can say there are total 3 types of address bindings which can be, you know, achieved. These these types of address bindings basically depends on you know, when you are performing this binding process, or when you are performing this translation and then, you know, process of binding. So that could be one idea is at the compile time, another one is at the load time, and third one is at the time of execution. So basically 3 times in the whole process of execution of a program. One is compile time, another one is load time, and third one is the execution time. And here we have, you know, address binding done at compile time, then we have address binding done at the load time, and then address binding done at the execution time. So coming to, you know, kind of detailing all these 3 types. So first of all, please make a note of this, that compile time and load time address binding methods generate identical logical and physical addresses. This actually means that whatever logical and physical addresses are generated by the method of compile time address binding, or if it is even, you know, done at the time of load, which is load time address mapping, then, or address map binding, sorry. So, load time address binding, these two methods are going to, we can say, generate identical logical and physical addresses, while the third one, which is the execution time address binding, which is a different scheme from these two, that results in differing logical and physical addresses. So, logical and physical addresses generated by the execution time address binding process or scheme is different, and the compile time and load time address binding method are going to give you identical logical and physical addresses. Now, when we talk about the term logical address space, or when we talk about the term physical address space, what do we actually mean by this term address space? So, let us try to see that. An address space is basically, we can say, a set of addresses. So, when we talk about the logical address space, that is the set of all logical addresses generated by a program. As I have told you, that program is not going to deal with, or user is basically not going to deal with the physical addresses. Whatever addresses are initially generated by the program are logical addresses, and the set of these logical addresses generated by program is known as logical address space. Similarly, these logical addresses are going to be converted into physical addresses, and there will be a set of all physical addresses corresponding to these logical addresses, and this is known as physical address space. So, we have a set of logical addresses, logical address space, then this is to be converted into set of physical address space, that is known as set of physical addresses, and this is known as physical address space. Now, coming to these processes of address binding. So, the first process which we are going to see is compile time address binding. Now, as the name suggests, compile time address binding, that means this is basically done when the program is being compiled, and now the question comes up, who is responsible for this? So, the component, or we can say the module which is responsible for this is actually the compiler. Compiler is one who is going to perform the compile time address binding, and for this the compiler needs to interact with operating system. So, in order to perform this compile time address binding, the compiler is going to deal with or interact with operating system. So, what is actually happening in this compile time address binding? Let's try to see that. When a program is executed, it allocates memory to a system, to the system code of the computer. So, whenever program is going to be executed, a memory area is being allocated to the system code, and the address binding assigns a logical address to the beginning of the memory segment to store the object code. Now, whenever we have this object code has to be, we can say, stored somewhere. So, if it is to be stored, then a logical address is, we can say, logical address to the beginning of the memory segment in order to store the object code will be assigned. So, that is what that object code is being given a memory location, we can say, and this time when the program is being compiled and a logical kind of address space is being assigned, this process is known as compile time address binding. So, till this point your program is being assigned a logical address. It has not been converted into physical address or any other address. Presently your program is having logical addresses only. Now, the next type, which is load time address binding. Now, as the name indicates, load time address binding, that means this type of address binding is to be done at the time of, we can say, loading the program. So, basically, or we can say this is to be done after loading the program in the memory, and it would be done by the operating system memory manager, that is the loader. So, loader is the component which is responsible for load time address binding, and this load time address binding, unlike the compile time address binding, is being done after the program is being loaded into the memory. Now what is happening inside this process, let's explore that. If memory allocation is specified when the program is assigned, no program in its compiled stage may ever be transferred from one computer to another. So now this is about the importance of load time address binding. So what I am trying to say here is, if a final memory allocation is given to the program whenever it is being compiled, then the portability of the programs or portability of the softwares will be killed. That means no program in its compiled state may ever be transferred from one computer to another. But you all are aware that yes, we do this. We can take compiled version of one program, a compiled version of a program from one particular machine to another machine. That means till this point, memory allocation has not been, we can say, sealed or not been ceased. It is, kind of still a chance that this memory allocation is to be, we can say, changed in the upcoming steps. So memory allocation in the executable code may already be in use by another program on the new system. So because of this, so for example, as we have seen that at the time of compilation, let's say a value x of the memory is being assigned to this particular program and it is being seized, we can say, and the address is actually a physical address, not a logical address. So physical address means I am talking about the exact address of the memory right. So now what will happen if I am going to take that compile time version to another machine? Is it necessary that the location X on the next machine is also free, so that that location X is to be allocated to this program? No, it is not necessary. So we can say that memory allocation in the executable code may already be in use by another program on the new system. So that's why this concept is going to kill the portability if the memory allocation is done at the time of compilation. So in this case, if this is being killed, that means the logical addresses of the program are not connected to the physical addresses until it is applied and loaded into the memory, and that's why this is what you call the load time address binding. So here till this point in this lecture, what we have seen is what actually address binding is and what is the need of this address binding, how a program and at what steps a program is looking for this address binding, and in all forms. So we have seen address binding is mapping of one type of addresses into the another. So for example, logical addresses which are generated by the program and the actual physical memory addresses. So logical addresses are to be mapped onto the physical addresses, and this process is known as address binding. Now how many types of address binding are there? So there are three types of address bindings. One is the compile time address binding, another one is the load time address binding, and third one is the dynamic address binding or execution time address binding. And we have seen compile time address binding and load time address binding in this lecture. I will be taking the execution time or dynamic address binding in the upcoming lecture. Hope you have enjoyed the lecture thoroughly, and here is a list of references which is being used for the preparation of the lecture. I will see you in the next one. Till then, goodbye.